Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this question, we're told to consider a line formed by the connection of 2 points on a Cartesian plane, point A with coordinates x1 and y1, and point B with coordinates x2 and y2. Derive expressions for the gradient, midpoint, and distance of the line in terms of x1, x2, y1, and y2. So this is an interesting question because effectively what it's getting us to do is to prove the formulas that ultimately most students would go on to memorize for gradient, midpoint, and distance. So they're the key concepts in coordinate geometry. You might learn them maybe year 8, year 9, maybe year 10, it kind of depends, but you kind of learn them during high school. Typically you commit them to memory and make use of them in various questions. But the interesting thing about this question is we're kind of being asked from first principles to prove what those results are. And I'm always a big fan of proving results and formulas because that way, over and above memorizing, you can actually get a deeper understanding of what you're dealing with. And in a worst case scenario, if you forget a formula, you'll always have a chance of deriving it from scratch if you ever had to, if you've been through a process like this where you've gone about going through the proof. So to kick off with this question, I've drawn up a Cartesian plane. I think it makes sense to think about this question visually. If this is new to you, a Cartesian plane, it's just the fancy word for the x and y axis. I think it's after René Descartes, who was a French mathematician who kind of came up with the technique, so it's named after him. But yeah, you don't need to kind of be put off by what sounds like a technical term. It's just the x and y axis. So we're told in the question that we've got 2 points A and B, so I might just draw them. It doesn't really matter where I put them, so I might put, say we'll put this as point A, and we'll put over here point B. And we're concerned with the line that joins those 2 points. So there's 3 things we want to know about this line. It's gradient, or how steep it is. The midpoint of the line, what's the coordinates of the point that's exactly halfway between A and B on the line. And then the distance, how long is the line. And it's all in terms of x1 and x2 because we've got point A as being defined as having coordinates x1 and y1, and point B as having coordinates x2, y2. And because these are just generic, we can't actually pull out our calculator and, you know, just plug in numbers. We've got to think about the concepts here. So what might be helpful is maybe in a different color, maybe in red, I'll just annotate on kind of what these coordinates mean. So the x1, y1 for point A means that from the y-axis, we've gone across a distance that is x1. So this distance here is x1, whatever that value happens to be. And y1 means from the x-axis, the horizontal axis, we've gone up a distance of y1, whatever that happens to be. And similarly with point B, this distance from the y-axis all the way over to point B is some value y2. And this distance from the x-axis all the way up to point B, that's x2. So the horizontal distance is x2 and the vertical distance is y2. And I think it's helpful to draw this up on the diagram because the first mistake that you could make, apart from mislabeling, is to think that the distance from here to here is x1 and the distance from here to here is y1 or y2. Or you could easily see how you could make mistakes on that front. So just remembering that x1 and x2 are starting from the vertical axis, and y1 and y2 start from the horizontal axis, and often a diagram can help clarify that. Another thing before I jump into deriving these results that at least on the diagram might help, maybe I'll just use green here. You can kind of hopefully visualize a triangle, and specifically a right angled triangle that gets formed in relation to these points. And this triangle is going to come in handy, particularly when we get to thinking about the distance of the line, because hopefully if you've learned Pythagoras, you can see that that's going to really help us when we get to that. And it might be worth just annotating on, well, what is the length of this side and this side of the triangle? So if we think about this length here, well, we know up to this point is a length of x2, and up to this point is a length of x1. So between here and here must be all of x2 minus x1. So this length would be x2 minus x1. And similarly, if you think about the height of this side of the triangle, the height all the way up to point B is y2, and the height up to the starting point of the line is y1, so the height of this would be y2 minus y1. Alright, I think having now drawn all that up, we're in a good place where we can start to derive some of these results. So maybe I'll start with the gradient, so the steepness of this curve. So I'll just maybe write here gradient. Typically we use a lowercase m to represent gradient. Don't ask me why, I don't actually know off the top of my head. But you'll see that quite commonly. Hopefully in your earlier math you've learned that the gradient of a line is what's called the rise over the run. And in that terminology, the rise is how much the line rises, and the run is how much horizontally the line runs, I guess is how you can think about it. So now you can see why it was helpful to think about the distances of these two lines, because they're effectively the rise and the run. So here our rise is y2 minus y1, and our run is x2 minus x1. So actually this result, which is what typically students would commit to memory, is actually very easy to derive if you've thought visually about what you're dealing with in the Cartesian plane. It's really just the height of a triangle divided by the base of a triangle, really is one way to think about it. So again, there's no harm in committing that to memory. It's not a big formula, but I think it's quite valuable to understand really how you get to it, because it isn't a lot of work. It's very simple. If you had to derive it in an exam, it wouldn't take a lot of extra time. Panic boom! Alright, the next thing the question asks us to think about is the midpoint. So it's a point on the line that's basically exactly halfway between the points A and B. So I might just call it capital M for midpoint. And effectively, the midpoint will be made up of two coordinates. Just like all the other points are made up of an x coordinate and a y coordinate. Effectively, what we're doing is we're finding the x coordinate and the y coordinate of this point M. So maybe I'll just go through this over here. Midpoint M. So if we start with, say, the x coordinate, what would that be? Well, we know it will be halfway between here and here. So it's whatever point, and I probably haven't drawn it perfectly to scale here, but it's what is the x value that's halfway here. And remembering, we think about our x values starting at the vertical axis. So it's what's the distance from here that gets us halfway in this line. And so visually what you can see is, first of all, you have to go a distance of x1 just to get to the starting point. And then from there you have to move half of this distance. So you have to then also move x2 minus x1, which is all of this distance, divided by 2, because we only want to go halfway. And then if you do some simple algebra, what you'll see is that's x1 plus x2 on 2 minus x1 on 2. I've just kind of divided the two individually. And then that we can write as 1 x1 minus half x1 gives us plus half x1, because if you have 1 and you take away half, you're still left with half. So that'll be x1 on 2 plus x2 on 2. And then now that they're both divided by 2, I can just bring the denominator together. So that's going to be equal to x1 plus x2 on 2. And that result you can think about as the average of the two x coordinates. Because if you add up two numbers and divide them by 2, that's one definition of the average of two numbers. And that's really what we've got. You add up the two coordinates and you divide by 2. So that can be a helpful way to remember this. The coordinate is, the coordinate for the midpoint, the halfway point, is the average of the two coordinates. And we'll see a very similar outcome for our y coordinate, because here again we have to move up y1 to get to the beginning of this line and then keep going just halfway. So we're going to go a distance of y1 and then we're going to go half of this line, which is y2 minus y1 all on 2. And I'll work through the math again so that if you didn't completely follow the first time around, you can have another try because it's the exact same process. So that's going to be equal to y1 plus y2 on 2 minus y1 on 2. And that will be 1 minus a half of something leaves a half. So y1 on 2 plus y2 on 2. And then we can just bring that together as y1 plus y2 all on 2. So again, it's the average this time of the vertical coordinates. So therefore we can conclude that our midpoint M has coordinates x1 plus x2 on 2, y1 plus y2 on 2. And that's the answer for the midpoint. So now we've got just one last thing to work out, and that's the distance of the line. And typically we might use a lowercase d to represent the distance. So if we look at our diagram, what we're looking at is the length from here to here. And I'm calling that d. Now, as I mentioned before, we've got this right-angled triangle, which actually means this distance formula is very simple to derive, because we know that the hypotenuse of a right-angled triangle, which is what d is, the hypotenuse squared is equal to the sum of the length of the other two sides squared. So I can actually start by saying d squared is going to be equal to the sum of x2 minus x1 squared plus y2 minus y1 squared. And because we want just d, not d squared, we just take the square root. And we're only concerned with the positive square root because we're interested in an actual distance. And in terms of the magnitude of the distance, we don't really deal with negatives. It's just the positive magnitude that we care about. So it'll be the positive square root of x2 minus x1 squared plus y2 minus y1 squared, and that's the formula. And this is a good example where you might look at that, and if, for example, your teacher said, well, just memorize it, it might look a bit daunting to have to commit to memory, although once you've used it enough times, it's easy enough. But actually deriving it is so simple because it's just Pythagoras' theorem, which you've probably already memorized. And so if you can just visualize what you're dealing with in the coordinates, the Cartesian plane, it's actually a very easy thing to memorize. So if you're worried that you're in an exam and you've got your minuses the wrong way, or are you meant to square these things? What do you do? To kind of help check what you're working with, you can just try and derive it. So hopefully that's been helpful for you. If this is kind of something new to you, you're just learning it all for the first time, I really do encourage you to not only commit these results to memory, but also commit the process of this proof to memory. Get comfortable with deriving these results, because it will help you with checking your work. And often in exams or when you're dealing with mathematical questions, the mistakes aren't necessarily made because you don't know the concept. It's just because you've kind of made a silly mistake. And having ways to check what you've done is the way that you kind of overcome those mistakes. And one way of checking whether you've remembered the formula correctly is always being able to derive it. So if you did find that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.